Modern cars employ a range of sensors to ensure efficient and sustainable engine running. Sensors in different cars may have somewhat varied names and numbers, but the overall operation stays same. We'll take a look at the most common set of sensors used in gasoline injection engines. Let's begin with the mass airflow sensor. The mass airflow sensor, or MAF, is positioned in the intake system, between the air filter and the throttle valve. It determines the amount of air that enters the engine. Sensor readings are routed to the electronic control unit, which processes all incoming data and transmits control signals to the actuators. Based on the MAF measurements, the ECU determines the best amount of fuel to mix with the incoming air and sends a command to the injectors to supply the necessary amount of gasoline. Moving on to the next sensor. The throttle position sensor, or TPS, is situated on the throttle upstream of the intake manifold. It communicates the position and dynamics of the throttle movement, while the throttle valve angle adjusts based on the position of the accelerator or simply gas pedal. Based on the readings of this sensor, the ECU modifies how much gasoline the injectors supply. If the ECU receives a signal indicating that the throttle valve is closed, air will be provided via the idle air control valve. However, that was an outdated version of the throttle, the cable throttle. Modern vehicles use drive-by-wire throttles, which are operated by an electronic gas pedal via an electronic control unit that uses information from other sensors. Such designs require an additional sensor in the electronic pedal, specifically the accelerator pedal position sensor, while the throttle valve in this case is controlled by an electric drive. The electric drive uses the ECU's control signals to put the throttle valve in the right position, including at idle. The idle air control valve is no longer necessary in this design. The next sensor, the crankshaft position sensor, sits next to the crankshaft pulley. This sensor determines the position and rotational speed of the crankshaft. To allow the sensor to measure rotational speed and consistency, a toothed wheel is installed on the pulley. To identify the crankshaft's position, one or more teeth are removed from the wheel. The sensor may also be placed in other locations near the crankshaft, such as next to the flywheel. The electronic control unit uses sensor readings to time fuel injection and the ignition advance angle. The data on crankshaft rotational speed is also sent to the tachometer on the dashboard, while the information on rotation consistency can be used to diagnose misfires. Let's move on to the next sensor, the camshaft position sensor. In most cars, it is located near the camshaft and the cylinder head. The camshaft position sensor determines the position of the camshaft. In the most basic systems, the sensor indicates the location that corresponds to the piston's top dead center in the first cylinder during compression. The ECU analyzes sensor information to identify which cylinder to inject fuel into and ignite, which is required for multi-point fuel injection, where the injector supplies fuel to each cylinder individually. This sensor is also important for the adequate operation of the variable valve timing system. You will find more 3D video lessons in our Car Anatomy online course. Moving on. The NOx sensor is mounted on top of the cylinder block near the combustion chambers. In four-cylinder engines, it is found between the second and third cylinders. The sensor detects metal NOx in the cylinders, which are symptomatic of engine detonation. Prolonged detonation can cause severe engine damage. Sensor readings help the ECU to determine the optimal ignition advance angle. If the sensor readings exceed the safe threshold, the ECU adjusts the ignition advance angle to reduce engine detonation. Next, the coolant temperature sensor is located near the engine coolant outlet. For example, in the cylinder head, thermostat, or T of the cooling system. This sensor measures the coolant temperature. Sensor measurements have a considerable impact on cold engine operation, leading to higher idle speed, adjusted ignition advance angle, and richer air-fuel ratios. Such modifications occur until the coolant reaches its operating temperature. When the operating temperature is exceeded, the ECU turns on radiator fans. It should be noted that the fans can be turned on using a separate sensor, known as the fan switch, which is not connected to the ECU. Temperature information is displayed on the vehicle's dashboard. The oxygen sensor, also known as the lambda probe, is situated in the exhaust system, either close to the exhaust manifold or directly in it, upstream of the catalytic converter. Some designs use more than one sensor. An additional sensor is then installed right after the catalytic converter. These sensors measure the amount of residual oxygen in exhaust gases. The first sensor, called the regulating sensor, monitors the amount of oxygen at the engine exhaust. The second, known as the diagnostic sensor, detects the amount of oxygen at the catalytic converter outlet, evaluating how well it operates. The first sensor's measurements enable the ECU to calculate whether to enrich or lean out the air-fuel ratio based on the amount of oxygen in the exhaust gases. The diagnostic sensor data allows the ECU to detect catalytic converter failures. If it operates inefficiently, the control unit can put the engine in emergency mode. Moving on. The speed sensor is normally mounted on top of the gearbox. The sensor measures the rotational speed of the shafts at the gearbox output, which determines the final wheel speed and the vehicle's speed. One way to measure it is by reading the rotational speed from a special ring gear on the differential. Some vehicles are not equipped with a speed sensor. In this case, the ABS system sensors take over this function, operating in a similar way. Vehicle's speed data is delivered to the ECU, which then regulates the fuel supply based on the vehicle's speed and acceleration. The driver can view the vehicle's speed on the dashboard speedometer. The oil pressure sensor can be found at the beginning of the oil gallery, near the filter, or farther down the gallery, in the cylinder block and cylinder head. This sensor monitors oil pressure in the lubrication system. In most cases, the sensor readings do not affect engine operation and serve only as a warning to the driver about emergency low pressure. If the pressure in the system falls below normal, a warning light will appear on the dashboard. The intake air temperature sensor. It can be combined and housed in the same unit as another sensor, which is a mass airflow sensor. It can also be located separately within the intake system. This sensor measures the intake air temperature, which in turn helps determine its density. Based on the readings, the ECU will modify the fuel delivery to achieve the desired air-fuel ratio. We have reviewed the most common set of sensors used in injection engines. In addition, it is not uncommon to use the manifold absolute pressure sensor, or MAP. It is mounted on the intake manifold, or affixed to the vehicle's body and connected to the intake manifold by a flexible tube. This sensor measures the air pressure in the intake manifold. Based on the air pressure and temperature in the intake manifold, the ECU can compute the engine's airflow rate, allowing it to regulate fuel injection and ensure an ideal air-fuel ratio, especially when the engine has an external exhaust gas recirculation system. Functionally, this sensor can replace or supplement the mass airflow sensor, providing the ECU with more precise airflow data. This sensor is ideal for measuring airflow and pressure in turbocharged engines, which may have multiple such sensors in the intake manifold and other locations. It is often combined with an intake air temperature sensor. Here are a few other sensors that are not widely used or have little impact on engine operation. The exhaust gas temperature sensor and nitrogen oxide sensor. They are fitted in the exhaust system, upstream and downstream of the NOx absorber, which is used in cars with gasoline direct injection engines after the catalytic converter. The temperature sensor measures the temperature of exhaust gases entering the NOx absorber. This is necessary for operation with stratified charge engine, as well as for transitioning to NOx absorber regeneration modes and for protecting the system from overheating. The nitrogen oxide sensor measures the concentration of nitrogen oxides after the NOx absorber. If the concentration reaches the threshold, the sensor indicates that the absorber is full and should be switched to regeneration mode. The next sensor is the clutch pedal position sensor. It is located next to the clutch pedal or sometimes on the clutch master cylinder. The sensor signal is used for a short-term decrease in fuel supply to reduce jerks and excessive increases in engine RPMs during gear shifts in cars with manual transmissions. It can also be utilized for other features, for example, to turn off the cruise control. Next, the brake pedal position sensor. It is mounted next to the brake pedal. In the most basic configurations, this sensor is a traditional switch that activates stoplights when the brake pedal is engaged. In more advanced systems, the control unit activates the stoplights when it gets a signal from the sensor. It can also perform additional functions, such as sending signals indicating the transient operation of an engine, turning off cruise control, and interacting with the ABS system. The next sensor, the EGR valve position sensor, is located in the external exhaust gas recirculation system. In simple designs, the valve position sensor monitors valve operability. In more sophisticated systems, it reports valve position, which improves the accuracy of exhaust gas dosing into the air-fuel mixture. In another configuration, use a differential pressure feedback EGR sensor. It detects the amount of exhaust gas that passes through the system, allowing for dosage into the intake manifold. Next, the engine oil level sensor. Only some cars include this sensor, which primarily informs the driver about the level of oil in the engine. However, in some cases, it can also communicate with the ECU to stop the engine from starting with insufficient oil. The rough road sensor. It is often found on the body next to the shock absorber mount. The sensor detects vertical vibrations in the body, allowing it to recognize is driving over rough terrain and report it to the ECU. This information is required to disable misfire diagnostics. Misfire is identified when the crankshaft rotates unevenly, which could be caused by a bumpy road. In the event of a sensor malfunction or inaccurate data, the ECU enters emergency mode, replacing the missing data with the average data stored in the ECU as well as data from other sensors whenever possible. In some cases, however, problems can cause the engine to stop running entirely. When the ECU detects erroneous or missing signals from the sensors during self-diagnostics, it alerts the driver with a warning light on the dashboard. This light may also indicate other issues. To discover the cause of the warning light, read the error code from the electronic control unit. This concludes our review of the sensors used in gasoline internal combustion engines.